Hello and welcome to Physics NP. I am here with some questions on viscosity. You can see uh, my first question on the screen, which is very common type of question regularly asked in the examination of grade 11 and 12. Uh, First question: castor oil at 20 degrees Celsius has a coefficient of viscosity 2.42 Newton second per meter square and density 940 kg per meter cube. Calculate the terminal velocity of a steel ball of radius 2 mm falling under the gravity in the oil, taking the density of steel as 7800 kg per meter cube, the value of g to be taken as 10 meter per second square. So here in the question we have oil. Oil at temperature 20 degrees Celsius, and as given the coefficient of viscosity of the of oil is 2.42 Newton second per meter square, and similarly density of oil is 940 kg per meter cube. And now a steel ball is dropped inside the oil, which is falling under gravity with some terminal velocity v that we need to calculate. And for this, the radius of the steel ball is given as 2 mm, that is 2 into 10 power minus 3 meter. Similarly, density of the steel ball is given as 7800 kg per meter cube. And now we have the direct formula for calculating the terminal velocity as v is equal to 2 by 9 r square density of steel minus density of oil into z by eta density of oil, viscosity of oil. Putting the values 2 by 9 into r square, 2 into 10 power minus 3 square into density of steel 7800 minus density of oil 940 into acceleration of gravity 10 divided by viscosity 2.42. So putting all these values and calculating, we get the velocity as 0.0252 meter per second as the terminal velocity of the steel ball which is falling downward. So this is the solution of the first question on viscosity. Another type of question for the same topic, viscosity, we have an air bubble of radius 1 cm is rising at a steady rate of 5 mm per second through a liquid of density 0.8 gram per cm. Calculate the coefficient of viscosity of the liquid. So here we have a some liquid whose density is given as 0.8 gram per cm cube, which is equal to 800 kg per meter cube multiplied by 1000. And in this liquid, an air bubble is formed and which is rising upward with velocity v. So the air bubble has radius 1 cm, that is 1 into 10 power minus 2 meter. Similarly, its upward terminal velocity is 5 mm per second, that is 5 into 10 power minus 3 meter per second. And now we need to calculate the coefficient of viscosity of the liquid. So we have again the direct formula for calculating the terminal velocity, 2 by 9 into r square, density of liquid minus density of air, into z by velocity. So since density of air is neglected as stated in question, its value is 0, taken as 0 since neglected. Now putting the values, 2 by 9 into radius 1 into 10 power minus 2 square into density of liquid 800 minus 0 into 10 by terminal velocity 5 into 10 power minus 3. So putting all these values and calculating, we get finally coefficient of viscosity as 35.56 Newton second per meter square. This is the coefficient of viscosity of the liquid in which air bubble is rising upward. Now here is the next question. A horizontal pipe of 25 cm square cross section carries water at a velocity of 3 meter per second. The pipe fits into a smaller pipe with a cross section of 15 cm square. Determine the pressure change that occurs ongoing from the larger diameter to a smaller pipe. So as question says, here is a pipe of changing cross section. Here cross section A1 is given as A1 is equal to 25 cm square, that is 25 into 10 power minus 4 meter square, and the water flowing through it is B1 given as 3 meter per second, and cross section area at the other end is 15 cm square is equal to 15 into 10 power minus 4 meter square. Now first we will calculate at what speed the water will come out, V2. So now using equation of continuity, A1 B1 is equal to A2 V2. So V2 is equal to A1 B1 by A2 as 25 into 10 power minus 4 into 3 by 15 into 10 power minus 4. Therefore V2 is equal to, on calculation gives 5 meter per second. So we get this value, 5 meter per second as V2. And now the question is pressure change. So if the pressure here is P1 and here is P2, so we need to calculate this difference. So here we will apply Bernoulli's equation. P1 plus 1 by 2 rho B1 square plus G H1 is equal to P2 plus half rho P2 square plus GS2, as uh, the pipe uh, seems to be at similar height. H1 and H2 are equal, so they are cancelled. We get P1 plus 1 by 2 rho B1 square is equal to P2 plus 1 by 2 rho B2 square, and P1 minus P2 will be equal to 1 by 2 rho B2 square minus 1 by 2 rho B1 square. This is change in pressure is equal to 1 by 2 rho B2 square minus B1 square. Putting the values, 1 by 2 rho density of water is 1000 into B2 we have calculated 5 and B1 is given 3. So putting all these values and solving, we get change in pressure as 8000 Pascal. So the difference in the pressure of A1 to A2 is 8000 Pascal. Here is the last question on this topic. Two spherical raindrops of equal size are falling through air with terminal velocity 10 cm per second. If these drops were to coalesce to form a single drop, what would be the new terminal velocity? So two drops of water falling down and coalesce to single bigger drop. Here given the terminal velocity of the smaller drop is 10 cm per second, that is 0.1 meter per second, P1. And now we need to calculate the terminal velocity of the bigger one. So here what we will do, we will consider the radius of bigger drop as capital R and radius of smaller drop as small r. Let R be radius of bigger drop and small r be radius of small drop. So since the two drop is combined to one drop, volume of big drop must be equal to 2 times volume of small drop, or 4 by 3 pi r cube is equal to 2 into 4 by 3 pi small r cube. R cube is equal to r cube, and the relation between the radius of the two drop is this. And now to calculate the terminal velocity, we will use the formula for terminal velocity of both the drops. Terminal for a small drop, terminal velocity is v1. 2 by 9 r square rho minus sigma g by viscosity. For big drop, v2 is equal to 2 by 9 capital R square rho minus sigma into g by eta, viscosity of air in which the drops are falling. We will divide this two equation. Dividing v2 by v1 is equal to r square by r square, and finally v2 is given by r by r square into v1, that is 3r by r whole square into v1 is 0.1, 2 whole 2 by 3 into 0.1. Therefore v2 is obtained as 0.158 meter per second. This is the terminal velocity of the bigger drop after coulees, and in centimeter 15.8 cm per second. Thank you everybody for watching this.